Welcome to Investigation 2.2. In this investigation, you're going to be looking at some taco trucks, but in this video, we'll be looking at burgers and fries, and then cantaloupes and watermelons, so we're sticking with the food theme. In this, we're going to be solving systems by combining equations, and this is part 1. In Investigation 2.3, you'll be looking at it in part 2 as more symbolic or numerical instead of purely with scenarios. So you're going to be looking more at the equations. So let's just get started with this whole concept. Here we get going. Justin and some friends ordered some burgers and fries at a restaurant, and Sally and some friends did the same. From the number of burgers and fries ordered from the two groups, can you determine the cost for a single burger and a single order of fries? So Justin's order is apparently 2 burgers and then 4 fries, and that comes to $40. And then Sally's order is 4 burgers and 4 fries. Looking at this, we can combine these two equations, we can combine these two scenarios and do the following to figure out what we have going on. If I look at this, I can either look at it very symbolically or I can look at it with just the symbols that are there. We'll first start with the symbols. When I see this, I want to think back to like those coins and the pouches that you had in 7th grade. In this case, instead of coins and pouches, we have burgers and fries. So I look and see how many burgers I have on one side. It looks like I have 2 of them. If I look at the other side, I have 2 matching ones. And so what I can do is I can essentially cross those out. So I'm just trying to find the balance. I'm trying to figure out how many extra pouches I have left over and how many coins I have left over on the other side. So I just got rid of 2 burgers on each side. And then I'm going to do that same thing with the fries. I look at this, I have 4 sets of fries that all have matching sets on the other side, on the other equation. So we're essentially doing a giant takeaway problem. And I eliminated all of this stuff in Justin's order, so I eliminated $40. And so if I were to subtract $40, I end up with $16 left over, and that is equal to these 2 burgers left over from Sally's friends. So those 2 burgers are equal to $16. So that tells me that one of these burgers is equal to $8. So if I were to use that information, I can go back and I can look at Justin's order, and I have $8 is equal to each burger. So that means there's $16 for burgers, 16, not 15. So I'm going to subtract that from 40, and I'll end up getting $24, and then that stands for my fries. So I have 4 sets of fries. That means each fry is worth $6. So the burgers are equal to $8, and the fries are equal to $6. So that's one way I can look at it, and one way that we're going to look at it in this situation. However, we're eventually going to get to the point where we're going to just look at it with pure numbers and variables. And so right at the very beginning, I wrote down 2b, and I wrote down 4f for Justin's situation, and we had 4b for Sally and 4f for Sally. So we can technically also turn this into a big systems of equations problem. So we'll do just that. And if we're going to turn it into a systems of equations, we're going to make our little bracket, and we'll end up with 2b plus 4f is equal to 40. And we have our other system of part of the system is 4b plus 4f is equal to 56. So doing exactly what I did above, essentially I turned this into a gigantic subtraction problem. I found stuff that was similar on both sides. So what we could do is we could technically say, I can take one of these equations away from the other. So this equation comes out to be less money, so I'm going to take this one away from my initial, or of Sally. I'm going to take Justin's stuff away from Sally's stuff. So I'm going to say 4b plus 4f is equal to 56, and I'm going to subtract 2b plus 4f is equal to 40 from that. So essentially, every single time I do this, I'm going to say 4b minus 2b gets me 2b left over. Then I have 4f minus 4f is equal to 0 f's. And then 56 minus 40 is equal to 16. So again, I have 2b is equal to 16, so I can figure out that my burgers, I'm going to divide by 2 on each side, my burgers are equal to $8. And from there, I can just do the exact same thing as what I did before. I can put that information back into my equation. If I have 2 burgers that are $8 a piece plus $4 for 4 fries, that is equal to $40, and I can solve for f. I can get this f all by itself. So I get 16 plus 4f is equal to 40. Subtract 16 from both sides. So I get 4f is equal to 24. Last but not least, we're going to divide by 4 on each side. So I just simply have f is equal to 6. And again, it's dollars, which is nice. So my burgers and fries, $6 for a burger, or $6 for fries, and $8 for burgers. So that's one type of problem, and you're going to be doing this type of problem in Investigation 2.2 over and over and over again, and it'll be nice and fun. Now there's another problem, and I'm going to take this, and it's going to be a little bit more difficult. We have cantaloupes versus watermelons, and maybe I'm spelling cantaloupes wrong. Cantaloupe on this situation is spelled with a U, and I'm thinking that may be a European version, like an English version. Sorry. All right, thinking to myself. So we have 3 watermelons and 2 cantaloupes weigh 32 pounds. 4 watermelons and 3 cantaloupes weigh 44 pounds. All of the watermelons weigh the same, and all the cantaloupes weigh the same. So that means if I have a cantaloupe, it's all they're gonna be $3 or 3 pounds each or something like that. What is the weight of 2 watermelons? 2 watermelons and 1 cantaloupe. All right, so let's do a little bit of math. Let's set these up with some symbols or some drawings that can help us. I'm going to do my watermelons in pink. Here's 3 watermelons to describe the first scenario. Let's try to make them a little prettier, a little less almond-shaped or something. I'm just going to turn them into circles. We have 3 watermelons, and we have 2 cantaloupes. So here are my cantaloupes, and they weigh 32 pounds. As well, we have 4 watermelons, 1, 2, 3, 4, and 3 cantaloupes, 1, 2, 3, and those weigh 44 pounds apiece. And we need to eventually find 2 watermelons, 1, 2, and 1 cantaloupe, and see what that weighs. We don't know how much that is going to be. So I'm going to do the same thing that I did in the past problem and see if that helps me at all figure out what this is all about. I'm going to find similar things between the top and the bottom. If I look at my first equation, I have 3 watermelons, and I have 4 watermelons in my second equation. So that means I could find the pairs and sort of get rid of them, and what's left over is 1 single watermelon. And for my cantaloupes, I have the same sort of thing. I have 2 sets, and I have 1 single cantaloupe left over. And if I essentially took 1 away from the other, I took 32 away from 44. That means I have 12 pounds left over. So 1 watermelon and 1 cantaloupe equals 12 pounds. So I know that this right here and what I want is going to be 12 pounds. Now I just need to figure out what this remaining watermelon's all about. So if I have 1 watermelon and 1 cantaloupe, that equals 12 pounds. And I have another watermelon and another cantaloupe, that equals another 12 pounds. and another watermelon and another cantaloupe, that equals another 12 pounds. So I have 36 pounds in this lower equation taken care of. That means if I had 36 pounds taken care of by a watermelon and cantaloupe pair, and I had 3 of them, then I can take that away from 44. 44 minus 36, and I'd get 8 pounds. And so that is what my remaining watermelon weighs, 8 pounds. So this final watermelon weighs 8 pounds. So 2 watermelons and 1 cantaloupe is equal to 20 pounds. So technically I'm done. However, it's kind of nice to know what a cantaloupe weighs. So if I know that a watermelon is 8 pounds, and I have 2 of them, and I know this total is 20, that means my cantaloupe, to balance everything else out, is going to have to be, let's make this a little prettier, it's going to have to be 4 pounds, because 8 plus 8 is 16, and 16 plus 4 equals 20, and that's our total. So play around with this whole concept of elimination, essentially taking care, or like combination, I should say, but I mean technically we're eliminating things. Play around with this concept of eliminating and combining equations, combining 2 scenarios, and investigate Investigation 2.2. If you have any questions, as always, please ask. Thanks so much for watching. Bye.